In this video, we'll be looking at examples of functions and deciding whether they're even, odd, or neither. From our last video, we learned that if we have a function named f, it is even if f of negative x is equal to f of x, and a function is odd if f of negative x is equal to negative of f of x. These conditions will help us determine when a function is even or odd. Now, before we get started looking at examples, I want to remind you of an exponential rule. If we have a product of two numbers, let's say a product of a times b, and I raise it to the power of n, then this power can be distributed to each of the factors. This expression can be rewritten as a to the power of n times b to the power of n. Now, let's take a look at some examples. So in our examples here, we'll be given functions and we'll want to decide whether they're even, odd, or neither. Our first example, we're working with f of x equals x to the n, where n is an even number. To determine when a function is even or odd, what you want to do is you want to plug in negative x into our function and see what the output is. We'll simplify them and see if it equals the original function or negative of the original function. So for our function, we want to look at f of negative x. So since our function is x to the power of n, f of negative x is negative x to the power of n. Our goal is to simplify this as much as we can and compare it with our original function. Now, one thing we can do if we look at negative x is we can rewrite this as negative 1 times x, all raised to the power of n. We can simplify this using our exponential rule here. We'll distribute the n and rewrite this as negative 1 to the power of n times x to the power of n. Now, since n is an even number, when we have negative 1 raised to an even power, this becomes positive 1. So this is just 1 times x to the n. And since 1 times anything is itself, this is just x to the power of n. Now, one of the main takeaways from this example is that when you have negative x and you raise it to an even power, you end up with just x to that same power. So we started off looking at f of negative x. When we simplified it, we got x to the n. Now, x to the n is the formula for f of x. So we can write here at the end that this is equal to f of x. And since f of negative x is equal to f of x, we can conclude that our function is even. In our next example here, we're looking at the function who's defined by f of x equals x to the power of n. This time, n is an odd number. Just like before, to determine whether a function is even or odd, what we want to do is look at f of negative x. We want to simplify this and compare it to the formula for f of x. So taking our function and plugging in negative x, we get negative x to the power of n. Again, we can rewrite the negative x as negative 1 times x raised to the power of n. And then using our exponential property here, we can rewrite this as negative 1 to the power of n times x to the power of n. This time, when we look at negative 1 raised to the power of n, since n is an odd number, negative 1 to an odd number will remain as negative 1. So this becomes negative 1 times x to the power of n. And this we can abbreviate as negative x to the n. The takeaway this time is that when you have negative x and you raise it to an odd power, it simplifies to negative of x to that odd power. So now let's compare f of negative x, which we simplified to negative x to the n, with the formula for f of x. We see that f of x is x to the power of n, and what we have here is negative of that. So we can conclude that this is equal to negative of f of x. Since we found that f of negative x is equal to negative of f of x, we say that our function is odd. With our two examples here, we kind of see why these properties are called even and odd. When we have x to an even power, we ended up with an even function. When we have x to an odd power, we ended up with an odd function. In our next example here, we have f of x equals x cubed plus 2x squared minus 3x plus 4. Let's check whether this is even or odd. And to do that, we're going to start by looking at f of negative x. So in your function, everywhere we have x, plug in negative x. So that's going to give us negative x cubed plus 2 times negative x squared minus 3 times negative x plus 4. From what we saw above, when we have negative x to an odd power, it's going to simplify to negative of x to that power. And when we have negative x to an even power, it's going to simplify to just x to that even power. So our first term simplifies to negative x cubed. Our second term would be 2 times x squared. Our third term, negative 3 times negative x, becomes positive 3x. And then at the end, we have plus 4. So what we have here is f of negative x. And what we want to do is compare this to f of x or negative f of x. Well, f of x is x cubed plus 2x squared minus 3x plus 4, which is different than what we have here. If we think about what negative f of x would be, it would be negative x cubed minus 2x squared plus 3x minus 4. And that's also different than what we have here. So what we have here is not equal to f of x, and it's also not equal to negative f of x. So for those reasons, we can conclude that our function here is neither even nor odd. Let's take a look at a few more examples. For example D, let's look at f of x equals x to the fourth plus 3 times absolute value of x minus 5. To decide whether this is even, odd, or neither, we want to look at f of negative x. So everywhere we have x in our function, replace them with negative x. This gives us negative x to the fourth power plus 3 times absolute value of negative x minus 5. When we have negative x raised to an even power, remember that simplifies to just x to that even power. Next, we have 3 times absolute value of negative x. What we're going to do is think about this as absolute value of negative 1 times x. And then we subtract 5 at the end. Now, if we have an absolute value of a product of things, it's the same as taking the absolute value of the first factor times absolute value of the second factor. This is because making a product of two numbers positive is the same as first making the numbers positive and then multiplying them together. Rewriting our expression here, we have x to the fourth plus 3 times absolute value of negative 1 times absolute value of x, and then minus 5. If we simplify this further, we have x to the fourth plus 3 times, well, absolute value of negative 1 here would just give us positive 1. And then we have times absolute value of x minus 5. And here, this 1, we don't really need to write down because 1 times anything is itself. So our expression is x to the fourth plus 3 times absolute value of x minus 5. So what we found out was that f of negative x is x to the fourth plus 3 times absolute value of x minus 5. We can compare this with f of x. F of x is x to the fourth plus 3 times absolute value of x minus 5, which is the same as what we have. So we can write at the end that this is equal to f of x. And since f of negative x is equal to f of x, we can conclude that this is an even function. Let's look at one last example. In example E here, we have f of x equals x to the fifth plus x cubed plus 4x divided by 3x to the eighth minus 1. If we want to see if this is even, odd, or neither, we want to look at f of negative x. So everywhere we have x in our function, replace it with negative x. So this gives us negative x to the fifth power plus negative x to the third power plus 4 times negative x, all divided by 3 times negative x to the eighth power minus 1. Once again, we want to remember that if you have negative x all raised to an odd power, it simplifies to negative of x to that odd power. And if you have negative x all raised to an even power, it simplifies to positive x to that even power. So our fraction here simplifies to negative of x to the fifth, and then minus x to the third, and then 4 times negative x gives us a negative 4x. All of this is divided by 3 times x to the 8th power minus 1. So this here is our f of negative x. And what we want to do is we want to compare this to either f of x or negative f of x. When we compare f of negative x with f of x, we see that there are some differences. Namely, in the numerator, each of the terms here have a negative out in front, whereas in the original f of x, they're all positive. With those differences, we see that f of negative x is not the same as f of x. So we can conclude that this is not an even function. The question is this an odd function? So let's take a moment and think about what negative f of x would look like. It would be negative of x to the fifth plus x cubed plus 4x divided by 3x to the eighth minus 1. Now this negative in front of our fraction means we're taking negative 1 and multiplying it to the fraction x to the fifth plus x cubed plus 4x divided by 3x to the eighth minus 1. Now, when we have a number multiplied to a fraction, we can take this number and distribute it to the numerator. This would give us negative x to the fifth minus x cubed minus 4x divided by 3x to the eighth minus 1. And now when we compare f of negative x, which is negative x to the fifth minus x cubed minus 4x divided by 3x to the eighth, it's the same as negative of f of x. So we can write that this is equal to negative of f of x. And since f of negative x equals negative f of x, we can conclude that this is an odd function. In this video, we looked at some examples and learned how to determine if a function is even or odd. Being able to tell whether a function is even or odd can be useful in helping us graph. For example, if we know that a function is even, we know that its graph is symmetric with respect to the y-axis. And if we know that a function is odd, we know that its graph is symmetric with respect to the origin.